Thank you. All right. Hi, everyone. Welcome. Thanks for coming to the first of our summer webinar series, which is focused on building technical skills for conservation. For anyone who doesn't know me, my name is Anna Weber. I'm the chair of the SCBNA Student Affairs Committee. So I'm going to turn it over to our speaker here in a few minutes, but before we do that, I'm just going to give a brief overview of what our organization is for anybody who may not be familiar with us. Okay, so SCBNA, or Society for Conservation Biology North America, we're the North American region of the broader Global Society for Conservation Biology. So we're a professional society focused on the conservation of biodiversity, healthy ecosystems, and human connections. And our mission is to provide a venue to connect diverse students and professionals to advance and apply conservation knowledge, and to welcome, support, and empower all voices engaged in conservation to contribute to equitable solutions and catalyze wonder for the natural world. So what that all boils down to is that we're a really big, diverse organization here to support anyone who's involved in conservation in any way. So we have a lot of biologists, but we also have people in social science, economists, conservation managers, et cetera. Really anybody who is involved in this field at all is welcome. So as a society, we try to provide professional development opportunities like this one. We also have biennial conferences, which our next one is in 2020 site, where you can learn more about us. So this session is being hosted by the Student Affairs Committee. Our goal is to really provide resources and support to students, both undergraduates and graduate students, as well as early career professionals. So we host skill building workshops, again, like this one, and webinars on various topics. We also do networking events and social events, primarily at our in-person conferences. So we have a good committee going right now, which, as I mentioned earlier, I'm the chair of the committee, at least until July. But if you're interested in being part of it and you're an SCBNA member and you want to help with programming for students, feel free to just send me an email. We can add you to our email list. So this is, as I said at the beginning, the first of our spring and summer skill building series, which is mostly focused on topics in data analysis and skill building. So today's webinar, which is going to be great, is focused on some skill building in R. And then after that, May 28th, we're going to have one on conservation genomics, which is, I believe, also primarily in R. And then we'll have remote sensing for conservation. And then later in the summer, we have a really good one on tips and tricks for Excel. We have some others kind of in the middle mixed in, which are still sort of being confirmed, but to see the complete list of our webinar series, you can go to our website. They're pretty much going to be every 2 weeks through summer until early August. So there's a lot coming down the pipe here for anybody who's interested. And they all get recorded and posted to our YouTube channel as well. So in a minute here, I'm going to introduce our speaker, Miguel Acevedo. He's the assistant professor of quantitative wildlife population ecology at the University of Florida. He's going to be teaching us about data science for conservation, again, primarily in R. So this is actually part 2 of a workshop that we did a couple of years ago, where Miguel introduced us to sort of R fundamentals. So this is an extension off of that. The original webinar is still up on our YouTube channel, I believe, which anyone is welcome to go and see if you're interested. But with that, I'm very excited to introduce Miguel. Go ahead and take it away.
Thank you, Anna, and thank you for everybody to be here. So a couple of things. So first, this is a follow-up on a previous workshop that we did. So I'm assuming that you already did that workshop. And what we did in that workshop, well, we went through what are the basics of R, all the way to sort of dealing with data frames and querying different data frames. We did a little bit of graphing and figures there, but not too much. So I'm assuming that you went through that. So you have a little bit of a basic understanding of R. Second, I'd like to share sort of my philosophy on this, like sort of short workshops. I think that R, different to other type of skills that we learn in conservation biology, it's more similar to like learning a musical instrument, right? So you cannot go to a 1-hour seminar and think, oh, now I'm an expert on guitar, I'm an expert in trumpet or whatever your instrument is, right? So you have to go home and practice every day. So in a similar way, we're gonna be talking about different things that we can do in data science in R, but this is just like a sort of 1 hour thing. And the way that you're actually going to learn this is you go home, practice, and sort of like play with it with your own data and all that. Okay, so the third thing I would like to share before starting is sort of how to engage here. So the first part of my talk, we're gonna do like a brief review of what we did in the previous workshop, just in case you did that workshop and your sort of our engagement hasn't been like every day since then. So we're gonna do a little bit on the basics, but we're gonna do that very quickly. After that, what we're gonna discuss in this one is how you're gonna build your own functions in R. And it's still a very basic, a relatively basic skill to develop in R, but it's a really important one. So we're gonna spend a lot of time doing that. So what we're gonna do, I'm gonna sort of introduce the topic, introduce some code, and feel free to follow on your end with your own R or RStudio or whatever you're using to run your R. Now, how to engage here? I'm gonna share my screen and make it big for everybody. Actually, it's highly encouraged that if you have a question to interrupt me. So please interrupt me. Because sometimes I'm talking, I will not follow the chat very much. So if you have a question, feel free to say, hey, Miguel, I have a question here, and I'll be happy to stop. And because usually whatever question you have, probably somebody else is gonna have it. So you might as well deal with it at that time. All right? Does that sound okay? Everybody there? Okay.
Sounds good.
Awesome. All right. So I'm gonna share my screen now. I'm gonna make it bigger. And everybody seeing my screen there? Okay, so what we're gonna do now is that we're gonna go through three things. First, we're gonna do a very quick review of what are variables, data frames, and functions in R. Then we're gonna go and we're gonna learn how to do and develop our own functions and maybe do some plotting of those. So let's see. All right. So just reviewing, we can use R as a basic calculator. That's pretty much what R is. It's like a very fancy calculator, and we can just do basic mathematical computations like 1 plus 2, and if there's justice in this world, it's going to tell you 3. You can also do all sorts of other computations like subtraction, multiplication, division. The symbol for multiplication is a star. The symbol for division is this slash. We can also, one of the most powerful things that we can do in R is that we can store information in variables, so we can do computation on those things later on. So for example, in this very basic example over here, I'm assigning the number 2 to the variable A. I'm assigning the number 3 to the variable B. And then I can just do A plus B. I can do calculations on those things that are already stored in the memory in A and B, and that will be 5. And I can do some other more fancy calculations with it, like, for example, A times 2 divided by 3 minus 1. Now, one of the important things here to remember is that all of those things that you learn in math about the order of operations, they actually matter, and R is using them, all right? So it's important to remember those order of operations. Now, another very powerful thing that we can do with R is to use functions, right? And we know that functions are a set of statements that perform a particular task. You might remember functions from your math classes when you say like a function f of x equals 2x. And basically those are machines, right? That get an input, they get an output. And in R, that's the magic of R. There's plenty of multiple functions to do whatever calculations you might think of, from something very simple as the summation to things that are a little bit more complex, like estimating survival from capture mark recapture data, or estimating abundance from count data and all that. There's a collection of functions to do that. And here we're going to start with the simple already made functions in R. For example, this summation function is called sum, and whatever it's inside is the input of that function. In this case are the values 1, 2, 3, 4. And if you sum them, and there's justice in this world, you're going to get a 10. There are other functions, like for example, here, there's a function for the arithmetic mean. What I'm doing here is that I'm saying in this object M, please store these particular values. These are values of SBL, or the sizes of lizards. And we have one here that measures 34.5 millimeters, 33.2 millimeters, 44.5 millimeters, and so on. I'm using the C here because I'm concatenating those into one single numerical vector that I'm saving in M. And then I simply say, well, what is the mean of M? And the mean of M is 45.63. So that's using sort of already made functions that we have in R. In R, we can also use logic operators, like, for example, greater than, less than, or and or. Those are very useful. And you're going to see, and again, I'm reviewing stuff that we did in the previous workshop, but those are super, super useful when we're dealing with data frames, when we're dealing with spreadsheets and data with multiple columns, and you want to make some queries of specific components of those data. Those logic operators become very useful for that. So in this case, we have a different type of object. In this case, we're saying these are lizard weights, and we have weights for 3 lizards. One measures 2.25 grams, 4.45 grams, 1.75 grams. And then I'm saying, are these lizard weights greater than 2 grams? And remember that computers, they think in zeros and ones, or true and falses. So what we're going to get if we do this, right? Lizard's weight greater than 2 is going to say true, true, false. Because in lizard weights, this one's greater than 2. This one over here is greater than 2. But this one that says 1.75 is actually not. Okay, so that's why it's true, true, false. And we can use that to query our data in multiple ways that we need to. Like, for example, if I want to have the actual values in this vector of numbers that are actually greater than 2, I will do something like this. Lizard weights, a lizard underscore weight, and then these brackets. And you can read these brackets in different ways. I suggest my students to think about these brackets with the letter where. For example, give me the lizard weights where lizard weight is greater than 2, right? So you read this bracket with the word where. So lizard weights where lizard weight is greater than 2, it's going to be 225 and 445, because these are the only two numbers in this vector that meet that criteria of being greater than 2. So that's like a quick, very, very, very quick summary of what we did last time. Last time we also talked about R packages. R packages are collections of functions for particular things. And we can also have packages that have cool data. And one of the packages that we're going to use today is this Palmer Penguins dataset. Super cool package. If you don't have it installed in your computer, you can go ahead and install it right now by using this code over here, install.packages and Palmer Penguins, and you're gonna wait for a little bit, you're gonna be able to install it. It's a really cool data set that has data on 3 different species of penguins, Gentoo, Adelie, and Chinstrap, in 3 different islands. And we have all sorts of data on them: bill length, bill depth, flipper length, body mass. And it's a really cool data set to sort of learn to explore ecological data. It's very real data in the sense that it also has those complexities that often data has, like, for example, missing data. Okay. And what we have in that data set, we already have it in that R package, but originally what it was a spreadsheet, right? And you're probably more familiar with this kind of format in your data, where you have every row, it's an individual, and every column is some sort of variable, right? So for example, species is one variable here, island, bill length, bill depth, flipper length, body mass, sex, and the year that the data was collected. And we have all the data already included in that package, Palmer Penguins. Another thing that we discussed last time was the $ operator that's going to help you access the information in a particular column. So for example, if I do penguins, $island is going to give me the information in that particular column called island. And I can do the same thing if I want to access species, or I want to access build length or build depth or whatever. I can just do penguins, $, and the name of that column, and that's going to help me access whatever is stored in that particular column. And again, I'm reviewing what we did in our previous workshop, so that's the reason I'm going a little bit faster on this. And also, we can apply functions, right? Already made functions to particular queries that we do on those data frames. Like, for example, I can take the mean of build length, for example. So we have penguins, $, build length, and it's going to give me a list of all the potential bit lengths. I can make that a little bit more restrictive and say, give me the build length where the species, penguin species, it's chinstrap. And you will know that instead of having all those numbers, I'm going to have only the numbers that correspond to that particular species chinstrap. Okay, so what we're doing in this case is that we're building a restriction based on a different column. And this is going to give me a vector of numbers that we have here printed out, and I can do the mean of those. And if there's justice in this world, and you take the mean, arithmetic mean of those, you see that the build length of those species chinstrap is going to be 48.83. All right, and I'm going to stop right here for a second and see if folks have questions, comments.
Can you just remind us again the name of this R package?
Yes, it's called Palmer penguins. I'm going to go back to the
Thank you.
yeah, no problem. And we used it in the previous workshop too. So if you went to that previous workshop and you haven't made any big changes to your computer, you should have that package installed in yours. But if not, you can install it again. Any other questions, comments? We can edit out the silences, so I can be here for a second just in case you have questions. Okay. So if you don't have any questions and you feel you're an expert in these things that we just discussed, let's go ahead and start thinking about building your own functions, do-it-yourself functions. And what are functions? There are self-contained chunks of code that makes a specific calculation. And in the previous slides, we saw, for example, the function sum or the function mean, and they make some sort of calculations. And they're super useful. That's literally the biggest components of what R is just a series of functions that we have built to make particular calculations. And the way they work is very similar in the way that functions work in mathematics, right? You have an input, and you're going to return an output. You're going to have an input, make a calculation, and return some sort of output. So the analogy is some sort of like this, like black box analogy, right? If you have an input that you're going to give your function, you're going to make some sort of calculations, and you're going to have an output. In the example that we did before, we had the function sum, right? So the input was the numbers that we want to sum. And here's the calculation of summing them all, and then the output will be the summation of those. The same thing happens with the mean. And actually, it doesn't have to be a black box, right? So usually we think about black box functions for things like in machine learning on AI. It's really difficult to see what those things are actually doing because those models are so complex and they change themselves based on data. So they're mostly black box. But most of the functions that we're going to create now, they're actually what they call white boxes, where we know exactly what the calculations are doing inside those white boxes. And today we're going to do like a really, really cool and delicious analogy based on coffee. So to make coffee, what do we need? Do we need coffee? Of course, like good beans. It does depend if you want dark roast, medium roast, or light roast, and water, and a cup. to just include them, right? So those are the inputs, right? And in the end, your output will be a delicious cup of coffee. So the way it works is that I include the inputs over here. The inputs are water and coffee, and I combine them there in this like third step. Then in the fourth step, I include the cup, and then I put them together in the cup, and I return my cup of coffee, and that will be my output, right? So that's a really cool like analogy on what is a function, right? And you can use the same analogy with any other thing that you can cook, right? If it's pizza, if it's spaghettis, if it's rice and beans, whatever you think, it's the same analogy. You get the ingredients. What the function does is to do sort of the cooking, the combination, all those calculations, and then what you get as an output is whatever dish you wanna eat. It's kind of obvious that it's 3 p.m. and I'm already hungry. But anyway, so let's do an example. So how many of you have seen this equation before?
I have seen it before.
You've seen it before? I'll bet you anything that all of you have seen it before. Because this is an equation for the mean, right? And you've been doing this since you care about your grades in school, right? To just calculate what's your grade in that class, right? So we can actually build a function, even though there's already made a default function in R to calculate the mean, we can practice and make our very own mean function, okay? So in this case, X bar, which is the mean, it's equal to the summation of all those values, right? From I to N, and N being the total number of samples that we have. And we can do that in R in a relatively simple way, okay? So this is a structure of a function in R. First, we got to give it a name. In this case, the name I'm calling it my mean, which means my function to make a mean. And then you got to type the word function, okay? And that's the way that we're telling R that whatever we're doing is actually making a function. Then the input is some vector, which is some sort of numbers or a series of numbers that we want to take the mean from. And then is the cooking, right? The meat of the function. A couple of things to observe here. Here's the name that I'm giving it. This is my instructions to R that this is going to be a function. This is the input. And then I have to have a curly bracket at the beginning and at the end of the function. That's very important. You have to have a bracket at the beginning and at the end of the function. And then here's the calculation. And here's the cool thing about functions is that you can actually use other functions inside a function to make some calculations. So for example, in this case, I'm saying my estimate is going to be equal to the summation of all those numbers in that vector divided by the length of that vector. And remember, the length in R, what it's going to give you is how many items do you have in that vector, right? So sum is going to sum them, and length is just going to give me how many do I have there, right? So if I have 10 values here, the length of the vector is going to be 10, okay? So that corresponds to that equation. Actually, if we go back to that equation, we see that we're doing exactly that, right? The first part, this is the sum part, and this is the length part. And this over here will be wherever I'm storing the data, right? And that's it. So you can actually write that on your R on your end. My mean equals function sum vector. And again, this name and this main name over here, you can make that up. Usually the rule is that you want those names to mean something for you, right? You don't want to just say happy face equals function another happy face, right? I mean, you can do that if you want to be funny, but you know, it's useful if they mean something so that people can read it and know what they're doing. Okay, so you can make all that up. Yeah, so this is the description of the equation that we have there. And the other requirement for a function is to have this thing over here called the return, which is this is going to be the output, right? Here we have one line of code, but you can have thousands of lines of code, right? You can have a very complex function doing a bunch of different things, but in the end, you want to return one thing, okay? And in this case, I'm returning the mean estimate, okay? So we can go and do an example with grades. So let's say that you're taking my population ecology class, and these are your grades on the exam. This is completely fake. I don't give that many exams in a semester, but let's just say that you have 87, 96, 81, 85, 92, 98. And I want to use my function to see what is my average for the semester. Will I get an A? Will not get an A in my class? We'll see. So first, I'm just gonna just for practice, I'm gonna say, what is the summation of that? And the summation of that is 539, and the length of grades is 6 because I have 1, 2, 3, 4, 5, 6 values. Okay, and you don't have to do that, right? Because you already have a function that is gonna do it. But I'm doing this here just to show what are these components of the function are doing. Okay, so one is summing them, and the other one is telling me how many items do I have. And then I just simply say my mean, which is the name that I give my function. And then I enter the vector, and here it is. We have 89.83, almost an A. Is this an A? I don't know. So that's it. So let's do an exercise, okay? So take some time and use the Palmer Penguins data and use your own function of my mean to calculate the mean build depth of chinstrap penguins. I don't know if this is a good moment to stop the recording or if you're gonna let it record and edit it later. But let's just stop for a couple of minutes